morning and welcome to Science Radio. In today's segment, we continue with our series on the workshop Hippocampus from Synapses to Behaviour, held at IISER Pune from the 1st to the 3rd of December 2013. In the previous episode, we heard from Dr. Upinder Bhalla from the National Centre for Biological Sciences at Bangalore, Dr. Trygve Solstad from Kavli Institute for Systems Neuroscience in the Norwegian University of Science and Technology, Dr. Jonaki Sen from the Indian Institute of Technology at Kanpur, Dr. Tom Bartol from Salk Institute in California, Dr. Mayank Mehta from the University of California, Los Angeles, and Dr. Vidita Vaidya from Tata Institute of Fundamental Research at Mumbai. Today, we will find out how these eminent researchers got interested in neuroscience. Also hear from some enthusiastic budding researchers who presented posters in the workshop. This is Science Radio on Vidyavani 107.4. Prashant Biraka and Sadhna Panzare are here with me today to take you through the workshop on Hippocampus, from synapses to behavior.
Hi, this is Sadhna with Science Radio.
Hi, this is Prashant with Science Radio. In the previous episode, we heard from some of the leading neuroscientists across the globe about their research interests. Today, we will find out how they got interested in neuroscience. They had some fascinating stories to share.
I actually started out with a physics degree, a bachelor's in physics. And so at the time, I had to make a decision between physics and biology. And in the end, I chose biology, and I was very glad I did. I rotated through various labs to decide what to do. I'd always been somewhat interested in neuroscience, but I went into a neuroscience lab, that of James Bauer. This was when the field of computational neuroscience was just getting started. And I thought the work they were doing there was absolutely wonderful. And so I started to do computational neuroscience and experimental neuroscience both.
I was actually in mathematics, and I was interested in cryptography. I was set on doing a PhD in cryptography. And then I started reading about psychology. And I got very fascinated about people who could remember, for instance, 100,000 digits of the number pi. And some people can remember 50 decks of cards, playing cards, after just looking through them once. And I was very fascinated, how can they do this, and can I learn it? And this would be amazing, you know. There's also a chess player. There's been a recent world championship in chess in Chennai. And chess players have amazing memories. They do this thing for show that they call blindfold chess. When a chess champion has a scarf across his eyes and he plays 10, maybe up to 50 players at the same time. And the world record is set by Miguel Najdorf in the 50s. Played 50 players at the same time, blindfolded. And he won almost all of the games. So you must remember all these games at the same time. How can you do this? So that was what got me interested in the brain, learning about methods for remembering. And I got into this new neuroscience project in Trondheim, Norway, where they studied spatial memory in the lab of Edvard and May-Britt Moser. And I asked them very persistently if I could join their lab, and finally they would accept me, and I was very happy after that.
I would like to state that I'm probably a developmental biologist first and a neuroscientist second.
Okay.
So the reason that I study neural development is because I started with studying pattern formation in the early embryo in Drosophila, and then I got interested in the development of the nervous system. And then when I did my postdoc with Connie Sepko, I worked on the development of the retina. And now in my own lab, I have started looking at other parts of the brain as well, one of which is the hippocampus. And other than that, I study the visual system, the pathway that goes from the retina to the pseudotectum to the other higher visual centers in the brain.
Ever since I was a little boy, 6 years old, I knew that I wanted to know everything there was to know about this part of our body that lets us see and feel and hear and touch and taste and think. And then when I went to Cornell University as an undergraduate and started to take instruction in neuroscience, I realized then that I wanted to be a neuroscientist doing research. So to be doing that now is really part of the fulfillment of my lifelong dream, and I feel very blessed to be able to be doing what I'm doing.
I was always interested in understanding space and time. So my PhD was in quantum field theory, where I was studying how the space-time began and how did space-time itself interact with matter and how do the two influence each other. And then the natural offshoot at that point was to say, well, it's nice to study the structure of space-time in the physical world, but how does the brain process the structure of space-time right now? And that was the natural way that I got into this whole business.
Probably the earliest memory I have about this is a talk I attended when I was about 10 or 11 years old. I grew up on a research center campus, and for all the kids who grew up on the campus, speakers who used to come to the research center campus used to also sometimes give public lectures. And there was a public lecture by these two professors, and the last name I remember is Schenkel, and they were talking about aggression in hippopotamuses and the underlying behaviors that might regulate aggression. And I was just fascinated that somebody could study something like aggression and do it in the way that they did. And so I found behavior fascinating very early on. I didn't really know that it was brain circuits that regulated behavior when I was a 10-year-old. But soon after that, when I was about 13, I got my first book about the brain. And by then, I was beginning to start getting hooked at the idea that the nervous system regulates extremely complex behaviors. And it matured from there. I knew I liked biology. I knew I didn't want to do medicine. That was a very early decision that I knew I was not going down the road to take medicine. Both my parents are medical doctors, and I'd somewhat seen firsthand what it was like to be the child of two medicos. And I knew I didn't want to do medicine. Life sciences it was, and behavior was just fascinating. I still find behavior in the wild particularly fascinating. I don't do anything like it, but I love listening to talks about neuroethology and behavior that really involves looking at complex behaviors out in the wild. So yeah, that's the original inspiration.
This is Science Radio on Vidyavani 107.4.
The workshop, Hippocampus from Synapses to Behaviour, organized a poster session which attracted some of the brightest students from across India who presented their current research. First, let us hear from our local coordinators, Dr. Collins Assisi and Dr. Suhita Nadkarni, about the motivation behind the poster presentation.
It's wonderful to have people discuss their work, but given the time scale that we have, very few people can actually give a talk on stage, just because we wanted it to be pedagogical, so each person was given a reasonably long duration to talk. So it was about 45 minutes or so, including questions. We wanted a forum wherein there'd be an opportunity to discuss this with a lot of people. And our experience has been that posters are a great place to have something like this, where there are no time limits and the duration of your discussion extends and is just held by your interest. Some of the posters were actually really excellent. In fact, I was talking to one of the speakers after they'd visited a particular poster that did some work on imaging, and he thought that it was really world-class stuff. So I think the quality of some of the posters was quite spectacular.
Of course, the regular hazard with poster presentation is that somebody inadvertently loses their poster. So there was that too. So there's this last minute rushing to the printers to get the poster printed. But I think it all worked out fine in the end.
We will now hear firsthand from 3 of the participants in the poster presentation.
Hello, I am Aditi Singh from NCCS Pune. I am working as a PhD student under Dr. Joman Joseph. I am here to present a poster which entitles Nuptriptate interacts with disheveled and APKC to regulate neuronal polarization. With this work, we are showing a novel role of Nuptr58 apart from the nucleocytoplasmic role, or the exchange of cargoes across the nuclear membrane. In our lab, we already found that Nuptriptate interacts with APC and regulates migrational polarization. So we wanted to check this polarization effect is getting affected when Nup358 is depleted from any other polarization model. We went ahead with neurons as our model system, wherein when we deplete Nup358 from the neurons, instead of single exon phenotype, we could get multiple exon phenotype. In literature, what is known is when Wnt activates disheveled, which in turn activates APKC, neuronal polarization is found. Since it is already known that disheveled and APKC are interacting with each other and are affecting neuronal polarization, we wanted to check whether Nup358 is also interacting with them. So we did endogenous Nup358 IP, where we could find disheveled and APKC coming in the immunoprecipitates. Then we went ahead with NUP358's role in the pathway. So where it is fitting in the pathway. We did a small experiment where we had 4 sets: control siRNA, NUP358 siRNA, disheveled siRNA, and disheveled and NUP358 siRNA together. What we find with NUP358 siRNA is more number of multiple exons, and with disheveled siRNA we get more number of no exon phenotype. When both of them are done together, that is disheveled siRNA and NUP358 siRNA, what we are getting is the multiple exon phenotype has gone down, whereas the no exon phenotype generated by disheveled is not affected. With this experiment, we can tell that NUP358 is playing upstream to disheveled. Now, with the case in PKC, we wanted to check how is this NUP358 regulating PKC. So we did a small experiment where we had 2 sets. One was control siRNA, other was NUP358 siRNA. There was again a subset in that where we added pseudo substrate to one set and other set was left alone. Now when we analyze the neurons after addition of pseudo substrate, what we get is more number of no exon, since PKC is inhibited by the pseudo substrate. In case of NUP358 siRNA, when we have the pseudo substrate as well, we could see the decrease in multiple exon phenotype, but the no exon phenotype is not affected. This means that NUP358 negatively regulates APKC. Now, to summarize the whole work, we can say that NUP358 is very important for neuronal polarization, and this work is adding to the number of non-conventional roles that have been shown for NUP358 apart from its role in nuclear cytoplasmic transport.
Myself Krishna Chaitanya. I am coming from Amrita University, Kerala. Today I am presenting on integrating spiking models for BOLD reconstruction. BOLD means blood oxygen level dependent signal. Generally, when there is an increase in neuronal activity, we can see that the blood inflow will increase as well as oxygen. What we are trying to see is how we can use spiking models for reconstructing this BOLD activity. So we use spiking models and reconstruct large networks. On those large networks, we try to reconstruct BOLD activity. So this BOLD activity can be reconstructed using a mathematical framework which has been earlier published in previous studies. We use that mathematical framework to reconstruct this BOLD activity. Basically, we give input stimulus and we observe the neuronal activity, and we convolve that neuronal activity with a hemodynamic response function which we calculate, and then we do a linear convolution and then we get a BOLD signal. After obtaining BOLD signal, we try to correlate with spikes as well as LFP. LFP is a local field potential. In a neuron, you can record intracellularly or extracellularly. Extracellular recording is LFP, which is local field potential. So studies suggested that LFP is more closely correlated to BOLD activity rather than spikes. So we are trying to validate that in our work in future studies.
I'm Vishnu Thakre. I'm from Srinagar Institute of Pharmaceutical Sciences, Lonavala. I'm presenting the poster on the possible role of silymarin in cognitive and behavioral impairment in the CNS disorders. Here we are just hypothesizing the probable role of silymarin in various CNS disorders with emphasis to schizophrenia and depression, because it is thought that depression and schizophrenia, these are the two disorders, might be because of the oxidative stress. Oxidative stress, when there is the generation of free radicals, leads to impairment in these cognitive and behavioral parameters. So we have published some of the paper with silymarin. Why we have choose the silymarin? Since silymarin is known to produce potent antioxidant property in CNS and the brain, because it crosses the blood-brain barrier, and thus it improves the some of the cognitive as well as motor dysfunctions, motor impairment. Silymarin improves the some of the symptoms in ischemia. Based on those experimental findings, because it's antioxidant nature, since here we are just focusing on the depression, it could be because of the oxidative stress, where there is an impairment in the endogenous antioxidant defense system. So whether silymarin can be able to restore the antioxidant defense system, or can we reduce the oxidative stress by increasing the antioxidant defense system, that is SOD catalase superoxide dismutase. In that sense, we are just focusing on the possible role of silymarin in this disorder by its antioxidant property.
This is Prashant.
And this is Sadhna.
Signing off.
That's all the time we have in today's episode. Tune in again next week for the concluding episode on the series Hippocampus, from Synapses to Behaviour, where we find out what the future prospects of neuroscience research are in India and get a little wiser about how to succeed in the world of research. Do write to us. Our email ID is Radio IISER Pune, Radio IISER Pune @gmail.com. This is your host Saurajit Basu signing off.